So we've already posted the links to the slide online. So if you want to follow along.
So we want to start with a story. So take the subscribe method. Now we use it for RxJava. The RxJava portion of that is not really relevant. All that you need to know really about this is that it takes a callback. The callback is, just click, there we go. So the callback gives you just a value and then you can do something with it. Now, years ago at Uber, we had this problem with error handling coming from RxJava. Specifically, people didn't seem to know that this could crash if an exception came through. And basically, as a result, never really ever added error handling. So to try to improve this scenario, we banned its direct usage and gave it something a little bit more descriptive. It was super clever. So this was a base abstract class. It only had one abstract method. It was very easy to use. The IDE sort of auto-completed everything for you. And the other goal that we had with this was to have better stack trace information whenever an exception did happen. Anyone who's worked with RxJava is probably familiar with basically not being able to track down where an exception came from. Now, several years later, this was used ubiquitously in the Uber Codebase, but we now, things were different now. We had Java 8, which meant that we had Lambda syntax, but we couldn't use them for any of these usages. We also found out that it turned out that everyone just used this because a linter told them to, and not necessarily because they wanted to make a proactive choice about whether or not to have error handling there. So it wasn't really accomplishing the goal. And it was pretty annoying for people who wanted to use something like lambdas. So we went back and revisited it. And long story short was we figured out another way that works passively for the better stack trace tracking and basically removed the lint check and said, cool, you can now use lambdas, which was great. We also open sourced a stack trace tracking as a library called RxJava. Now, this is cool. Or not RxJava, RxDogTech. It's early in the morning over here, folks, sorry. So this is neat, but we still have all of these other usages. And now all of these are tech debt. Oops. So in a lot of code bases, this is sort of like an immediate forever tech debt. Like it still works functionally. It's not something that is ever really going to break in any sort of heinous way, and it's not really anything that's ever going to push a needle for, some sort of product cycle or release. It's going to be something very hard to find prioritization for. For us, though, we had thousands of usages of these, and we migrated them all in just a couple of days. No regressions, no formatting issues, nothing. But how, you might wonder? How exactly does one safely yeet thousands of files of tech debt out of a code base in such a short time? And that's what we'd like to talk to you about today, as lessons from librarians from multiple libraries. There's two of us. So a couple of years ago, Jesse Wilson gave a great talk called Writing Code That Lasts Forever. And we're going to talk about some similar things, but about code that other people write, not necessarily just your own code. So it's not really writing code that lasts forever, but rather helping everyone write code that lasts forever.
So as Zac was saying, we want to help others write good code. And the best way to start off with that is to help others write better code by having good examples of your good code in your code base already for them to learn from. But what is good code, you say? Well, that's ultimately up to you to decide. Some examples of a minimum bar for code quality might include such things as code that builds quickly, is sufficiently tested, and is well documented. On the other hand, some things that might detract from code quality are having duplicated code everywhere, using deprecated APIs, and not modularizing your code. Since it might be difficult for your team to agree on some initial criteria, I recommend that you start with some less controversial things and refine your definition over time. Once you select your initial criteria, you can then audit the health of your code base and collect data for each of these metrics. So hopefully you can automate your process with a CI job or a periodic task that does this for you. This would then allow you to create graphs and track the quality of your codebase over time, alerting on any major regressions to pop up. In order to summarize your health of your codebase quickly, you should create your own quality score. The score would be some combination of metrics, weighted towards the ones that you find to be more important. The score also provides a good way for you to set overall quality goals for the quality of your codebase.
So now that you've got your report card from Professor Barr over here, let's talk a little bit about this actual tech debt. Now, fixing is one thing, but obviously prevention is better. Your first line of defense in this is always going to be API design. Now, the basic principle behind this is that you can't misuse what can't be misused. Now, if that sounds vague, I don't have a better answer for you on that, but we can talk a little bit more in detail about it. So we could talk about this actually all day, or at least I can. I don't know if James wants to, but let's go through some simple principles. And remember that these are just guidelines. They're not rules or anything, but they're little things that if you apply them at a macro level in your code base, I think you're going to see a lot of benefit over time. So one of the easiest ways is basically limiting API surface area whenever you're writing anything that's going to be shared or used by other people. This is also one of the easiest ways. It's multifaceted. The basic principle here is that a good hammer isn't also a good screwdriver. There's a few easy examples of this in practice. Say we have this hammer class here. Do we intend for this hammer to be anything else? No? Well, then make it final. In fact, you should go for final as your default. If you're working in Kotlin, this is the default. If you're working in Java, it's unfortunately not. But you can make it a practice to get in the habit of this. There's a few other easy things to control here. Visibility is a big one. In my clicker, there we go. So in my opinion here, private by default should be your go-to. If you're working in Java, you get a little bit of help here where package private is the default. If you're working in Kotlin, public is the default, which is unfortunate. Then once you have everything out the gate, you can start moving things up through internal, protected, package provided, things like that as needed. It's much harder to basically take something away than it is to open up something down the line. And lastly, factories. So factories can often replace constructors with more meaningful names. They give you flexible control over construction of an object. You can return basically whatever you want, especially if you have objects that have either either base classes or return interfaces, things like that. Whereas if you're just giving access to constructors directly, then you're always going to be married to returning that type. And these three things alone, I think that if you really apply them over your code base with a good measure, you'll find that after about 2.5 years, you won't be pulling your hair out over it. Next is consuming interfaces. So this one is sort of a spin on the composition over inheritance model, or basically related to it. The principle here is that if you're working with code that your users can give you back implemented types of, then trying to keep yourself honest by only communicating with interfaces and not being able to accidentally let yourself assume implementation details about the types coming in will keep your code honest, and it will also lend your users the most flexibility. And that's all that we really want to cover on the API design of things. Basically, you want to ask yourself, how easy is it to do the wrong thing? And also, perhaps more privately to yourself, is this going to limit me in the future? There's two more macro level things that we want to talk about in this space, though. The first one is API versus implementation at a project level. I don't know what to do about this echo. Yeah, sorry. Now API implementation is probably not a new concept, but you can enforce this at a project level in a way that gets you a lot of benefits. So let's look back at our hammer here. Now, right now it's under, say, a Hammer project. And we might have other projects that use a Hammer and nail APIs under the hood. Now, Hammer might be passed into our libraries here, which unfortunately had the same name, so this is a very basic example. They might be accessing a Hammer instance via dependency injection that's controlled at the app level, something like that. But right now, every time we recompile Hammer, then we're actually imposing that downstream with a forced recompilation of everything that depends on it. So another approach that I'd like to talk about is separating API and implementation modules. So the principle here is that we just take out the API components and we keep implementation details in a separate module. And then if someone just needs to communicate with an API and is not really handling management of instances, then you can actually just restitch our dependencies in such a way that our libraries just work with the API, and our app is the only thing that works with managing the instance. And then when we recompile Hammer, only the app is recompiled. This gets you a lot of wins at both a visibility level, at a separation of concerns level. Your build system will build these in parallel, and you get a lot of compilation avoidance out of it down the line. It's a little bit of overhead up front to make these separate, but I think it almost always usually pays off. A good example of this in practice is separating out build config from the generated type with static content and interface to expose the app. That's a lot of feedback. So with build config, you're probably familiar with it from past projects. You get just a bunch of static constants. So pulling out an interface is very easy to do just from eyeballing it. You can put that interface into a API module, and you can then even pull out the implementation of it into another module and just make your app depend on it. It's very easy to set up, and then you can even run through and disable build config generation on any other project that doesn't have the real one. So here's some more resources. We can't dive into all of these today, but there's some great talks out there. Effective Java, as always, is sort of a great book for this, and an example of the app build config pattern that I just ran through. Now, we can't solve everything with API, though. Code review is important, too, and not all safety can be baked into design. Now, we don't have time today to really dig into code review, but there's two principles that I'd like to leave you with. Is basically find a code that doesn't scale for repetitive things. So you should keep them oriented around solutions, and just know that it's the most refined tool in your belt. It's what's going to get you the best result, but it's also the most expensive to wield. So as such, you want to make sure that you're not wasting it on bike shedding, which leads us to static analysis. Because you can't bike shed with a linter. Now, static analysis in my opinion is essential, especially if your team and Codebase grow beyond it. I don't know where this speaker echo is coming from. Sometimes it's sometimes it's preemptive, and sometimes it's retroactive. Our two sort of go-to types of static analysis are basically going to be lint and error-prone. There's other ones for more in the realm of one-off tools like detect is specific to Kotlin. But as far as like the two most popular out there, you're definitely gonna you're probably familiar with lint because it's baked into Android. Error-prone, if you're doing any sort of Java work, it's just sort of like a day one thing. Definitely recommend checking those out.
And now that we've created our new APIs, and we're linting against old API usage, it's time for us to refactor our code in order to reduce some of our tech debt. Let's take a look at some of the tools that we have available to us. To start off with, simpler refactors can just be done with a simple find and replace. This is available in IntelliJ or any other text editor. They usually have directory and file type filters, in addition to regex support for more complex replacements. On larger projects, you'll get better perf in the terminal. Using tools like find, xargs, and z will help you work faster when you're modifying thousands of files and avoid freezing your IDE. When you're working in Kotlin code, there's a useful feature for deprecations. The deprecated annotation signals that an older API should no longer be used, but in Kotlin, it allows you to provide a hint to the IDE. This hint is used to signal that a replacement is available, and that replacement can be done locally or even throughout the entire project. Another nice way to suggest code changes to engineers is with Android Lint. It's a nice choice because it analyzes Java, Kotlin, and Android XML resources. These suggested fixes show up in the IDE, giving engineers fast feedback and quick resolution without them even needing to run a build. Structural find and replace is just like the regular version, but with added code intelligence. It's especially useful when you're trying to migrate code that can't be easily distinguished with just a regex, as in this example on the slide. Now, IntelliJ has a wide variety of templates for this to start off with. In this example, we're starting with the method call template. Instead of entering plain text or a regex, it uses variables to represent parts of the abstract syntax tree, such as instances, method calls, and parameter lists. You can then configure the properties of these different variables, like type, count, and name, in order to refine your search. This particular way is how we did the crash on error consumer to Lambda migration, as mentioned in the beginning of the intro of this talk. One thing to note, though, is right now, this is only supported in Java, but you can follow along on the ticket at the bottom of the slide for updates on Kotlin. Now, IntelliJ is pretty powerful already, but if you need even more control, you can create your own IntelliJ plugin. I mean, don't you sometimes wish there was a built-in option to remove Hungarian notation? With a plugin, you can add your own refactor tools. And a plugin lets you invoke IntelliJ's refactoring tools programmatically. This is especially useful when you need to do many renaming or structural replace operations. We were actually able to leverage this to invoke structural replace many times in order to migrate AssertJ test APIs over to Google Truth. You can see a script at the bottom of the slide, which shows a similar script to the one that we used for our migration. Now, if you need even more customization, you can use a scripting language like Python or even Kotlin to transform your source files. This is especially good when you need to make transformations based on the output from another tool, such as a test failure report or a lint error report. This is actually how we did our Android X upgrade, because we were able to use the CSV files of the mappings between the old and new package and modules, since the migration tool was only available for Gradle users. Now, this turned out to be a pretty large change in our Android monorepo, but we tried to make it as safe as possible.
Speaking of safety, let's talk about de-risking change. So automation gives you a lot of confidence, especially when you can use a computer to do it for you. But computers, unfortunately, can't do everything for us yet. And also, not every change is necessarily big. Some are small but significant. Anyone who's upgraded place services has possibly at some point found out that you can measure the rollout of place services by your own crash reporting dashboard. It happens, and sometimes you just want to incubate those for a longer period of time between when it goes into master and when it goes to production. If you're working on a release train, your time in master, the time between landing in master and going to production might not be that long. So another option that I want to talk about here is shadow jobs. So what's a shadow job? A shadow job is a silent master job that applies and incubates a new change in sort of, we'll say effectively the background. We at Slack, we run this on a cron job. At Uber, their shadow job runs on, I think, every master push. It doesn't block anyone's PRs or diffs. It doesn't really make itself visible to anyone but the people who created it. And you can use them to test a new change with CI and let that incubate over time. You can also use this as a sort of crystal ball into the future, allowing you to update to, say, new stable versions of libraries with confidence, knowing that you've been building against in development versions of them. At Slack, we use this to build our repo against Android Gradle plugin 4.0 and 4.1, against Android X alphas, against Kotlin 1.4, which is currently at milestone 1. It really gives us a lot of flexibility here. Another thing that's worth mentioning, but we don't have time to dive into here, is offensive programming. So we all know what defensive programming is. Offensive programming is the opposite, and specifically look to be doing these harder in debug builds, where you basically fail quickly and explosively, because that's always going to be better than doing the same thing in production. And next, James will talk about unflaggable changes.
So when you can't feature flag or otherwise guard your changes for these big code changes, you should actually take some additional steps in order to improve the safety of these changes. One thing you can do is actually just build a copy of your app from a branch. That way stakeholders can test the changes before they actually get merged. This will reduce the probability of you having to actually revert this big diff. Another thing you can consider is whether you want to use multiple or a single commit. Now, multiple commits would allow you to just revert a portion of your change if something goes wrong. You also might need to use multiple commits in order to fit up your change through your CI pipeline. But if you're in a monorepo, then you might just have no choice other than do it all in one big commit. When it actually comes time to merge these changes, you want to be sure to do so after a build cut or a holiday freeze, so you can maximize the amount of time, soak time, before your change goes into a production build. You also don't want to thrash other engineers with rebase conflicts when they're trying to get their features in before their deadline. Now, after these large changes are merged, be sure to let other people know. Send an email to your engineering group, including the task details, the commit, and any rebase steps if possible. Bonus points if you can script them. And since communicating in large companies is difficult, also send a Slack message to your engineering group with the same information. And for larger changes, share the news at your weekly team meeting. And maybe even send a carrier pigeon or a raven to that one person that never checks their messages.
So to wrap up here, we've covered a number of different topics, anywhere from measuring your debt to how API design can help, code reviews, static analysis, refactoring migrations, and de-risking change. The most important thing to do at the end of all of this is make sure that you celebrate the work that you've done. We did promise tombstone cakes in our description, and one of our pastimes on our last team together at Uber was, in fact, to have tombstone cakes for celebrating large migrations that we finished. It's a great way to build a sort of culture and camaraderie with your team.
So we hope that some of these lessons that we've shared with you today will help you to keep your code base clean. Thanks.